Seventh graders, we are now going to be talking about two-way tables in section 11.4. So in this section, you're going to learn how to find and interpret marginal frequencies, make two-way tables, find relative and conditional relative frequencies, and use two-way tables to recognize associations in data. All right, there is a lot of information here. So here's your key concept for the first part. Finding and interpreting marginal frequencies. So let's just look over this to see what we're dealing with. So let's look at our chart first. In this chart, we have a class that's either a freshman or sophomore, and then do they have mobile access? Yes or no. So a two-way table is a frequency table that displays data collected from one source that belongs to two different categories. So as you can see here, two different categories. We have the category of class and the category of mobile access. For instance, the two-way table below shows the results of a survey that asked freshmen and sophomores whether they access the internet using a mobile device such as a smartphone. So in each of these categories, you will notice that it's class and mobile access, and within each class is divided into two. Class is divided into freshmen and sophomores, mobile access is yes or no. Each entry, so each of these, are called a joint frequency. So this is the joint frequency. This is a joint frequency. Let's think about what that means. Frequency is the number of times it happens, and joint means there's two things that form that. The sum of the rows and columns in a two-way table are called marginal frequencies. So these are joint frequencies. If I added the yes column and put a total here, that'd be marginal frequency. If I added the no column and put 34, that's a marginal frequency. Example 1 says, find and interpret the marginal frequencies for the two-way table above. So the two-way table above, I'm going to make this super easy. I'm just going to bring it down, and here it is. From above, remember again that the 55, the 22, the 63, and 12 are joint frequencies. The marginal frequencies are when you just total up the columns and the rows. So if you look here, 77 freshmen, 75 sophomores. Here, 118 students said yes, 34 said no. If you add these two totals or these two totals, you should get the same amount of 152 total students that were surveyed. So let's make a two-way table. You conduct a survey that asks 286 students in your freshman class whether they play a sport or a musical instrument. 118 of the students play a sport, and 64 of those students play an instrument. 93 of the students do not play a sport or instrument. Organize the results in a two-way table. Include the marginal frequencies. Step 1. Determine what the two categories are. Well, they are sport and an instrument. So from the chart, we should see that we have an instrument. An instrument is going to be yes or no, and sport is going to be yes or no. Now, once again, you could put sport up here at the top and instrument on the side. It does not matter. Now, we know that 286 students, so we know that's a total, 286, we put that here, are in the freshman class. Well, this whole thing represents freshman class. 118 students play a sport. So 118 would be yes for sports, that'd be the total. Then, 64 of those students, of the 118, also play an instrument. So this would be yes for instrument and yes for sport. So that's 64. Then it says 93 of the students do not play in a sport or an instrument. So the no column and row would be 93. So now we can figure out the remainder of our information. So 118 minus 64, that gives me 54 as saying they played a sport but not an instrument. We know that there's 286 total, so I could subtract 286 minus 118. That gives me 168. That means 168 is a total for this row. So 168 minus 93, that gives me 75. And now I can add up these two rows, and this would be 139, and this would be 147. So a two-way table is fairly easy to set up. You take the information. The hardest part is just determining what are your categories and what columns and rows should I put. Once you do that, it's fairly easy. Once again, each of these numbers inside are joint frequencies. All of these numbers, the totals, represent the marginal frequencies. Next up is finding relative and conditional relative frequencies. So you can display entries of a two-way table as frequency counts, as like we did in example 1 or 2, or as relative frequencies. So here's what relative frequencies are, right here. Relative frequencies are either a joint relative frequency or a marginal relative frequency. A joint relative frequency is the ratio of the frequency that is not in the total row or the total column to the number of values or observations. A marginal relative frequency is the sum of the joint relative frequencies in a row or column. When finding relative frequencies in a two-way table, you can use the corresponding decimals or percents. So this may not make sense to you. Let's do an example and I'll show you what it means. The number one thing I want you to take from this, though, is that we're going to be talking about decimals and percents. The two-way table shows the results of a survey that asked college-bound high school students whether they plan to major in a medical field. Make a two-way table that shows the joint and marginal relative frequencies. So here's my two-way table right here. We want to do the joint relative frequency and the marginal relative frequency. Here's how it looks. To find the joint relative frequency, you're going to add up the total number of people surveyed. So how many total people are surveyed in this problem? It would be 680. So if you added together all three of these numbers, you would get 680 people. So here's how you find the joint relative frequency. You take each of these numbers, 124, 219, 101, 236, and you divide it by the total. And that's going to give you a decimal. So we're going to find percent, so you could round to the nearest hundredth. So this gives you approximately 18 hundredths, 15 hundredths, 32 hundredths, 35 hundredths. Now what does that mean? That means, for example, here, 35 hundredths would be about 35% of students who are seniors are planning on not going into the major in a medical field. So this would be 15% of seniors say yes, they are going to go into a major in a medical field, and so on. Now, these are the marginal, rather than marginal frequencies, these are what? These are the marginal relative frequencies. So we add together the decimals. So these added together gives us approximately 50%, and the seniors added together gives us the same. What does that mean? That about 50% of the students are juniors and about 50% are seniors. About 33% said yes, they are majoring in a medical field, and 67% said no, they are not. Now there's a side note here, right here, the study tip. The sum of the marginal relative frequencies, so these two and these two that were down here, in the total row and column should be equal to 1. So this right here should always be equal to 1. That leads us into our next core concept, conditional relative frequencies. A conditional relative frequencies is the ratio of the joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or column total of the two-way table. In example 4, finding conditional relative frequencies. We're going to use the example we just talked about to make a two-way table that shows the conditional relative frequencies based on the column totals. So here I've just recopied the problem from the previous example. Now, in order to find the conditional relative frequency, this is a huge star, you're going to use the marginal relative frequency from each column. So remember, right here, this was a marginal relative frequency. This was a marginal relative frequency. So were these, but this is the total of the row. We only use the column here. So we take each of these examples right here. So for example, 1800ths. You can see that right here. We divide it by the 3300ths. So we take each of these decimals and divide it by the column total. So 1800ths divided by 3300ths. 1500ths divided by 3300ths. 3200ths divided by 6700ths. And each of those, as you can see, give us approximately 55%, 48%, and so on. Now, look at what it says here. Given that a student is not planning to major in a medical field, the conditional relative frequency is that he or she is a junior is about 48%. So that means we take the whole column of no. So 67% originally said no. Of that 67%, 48% would be a junior, 52% would be a senior. Once again, here's your study tip. When you use each column totals, the sum of the conditional relative frequency should be 1. So I'll put it right here, and then I'm going to move the arrow. Each of these should be 1. So if you added these together, it'd be 1. This should be 1. Now remember, we're only talking about columns here. So the sum of the conditional relative frequencies for each column should be 1. So recognizing associations in data. In example 5, we want to recognize what we're looking at. What associations are we talking about? So let's say we survey students. We survey students and find that 40% exercise regularly, 35% eat fruits and vegetables each day, and 52% do not exercise and do not eat fruits and vegetables each day. Is there association between exercising regularly and eating fruits and vegetables each day? So I'm going to start off by making a two-way table. Since we're talking about exercising, that's clearly going to be yes or no. And we're talking about eating fruits and vegetables. That will be yes or no. So I made a wonderful rough-looking graph here. Two-way table showing exercise daily, yes or no. Eats fruits and vegetables, yes or no. So it says you survey students and find 40% exercise regularly. So a total of 40%. So that means 40% will go right here at exercising daily. 35% do not eat fruits and vegetables. So that's the total. Now we have no clue if they exercise, but they do eat fruits and vegetables. So 35% total is fruits and vegetables. We know 100% has to be equal to everything. Now we also know 52% do not exercise and do not eat fruits and vegetables. So that'd be the no column. So this would be 52%. So now we have to fill in the rest of the chart. Since this is 100% right here, we can subtract each of these values from 100%. So this would give us 60%, and this would give us 65%. Now I could take 65% minus 52%. That makes this 13%. And now I take 40 minus 13 and 60 minus 52 to figure out the remaining cells, and that will give us this. So we have to use the given information to see if we can find an association. Now to find an association, we have to find the missing joint and marginal frequencies. So here's our chart. Now remember, what you have to do is you take each of these as a decimal and divide by the total in the column. So 27% is a decimal, 2700ths divided by 40%. 8%, 800ths divided by 600ths, or 6/10ths. 1300ths divided by 4000ths, or 4/10ths, and so on. And you will get these numbers right here. So what's our answer? Is there an association? Well, by looking at it, we can see this. This is huge. Those that do eat vegetables are more than likely to exercise. Those who don't exercise, almost 87%, don't eat fruits and vegetables. So your answer is right here. There obviously, absolutely is an association between exercising regularly and eating fruits and vegetables each day. Now, we can also find the conditional relative frequencies by dividing each joint frequency by its corresponding column total or row total. So remember, joint frequencies are just the numbers. Joint frequency. So in example 6, the two-way table shows the results of a survey that asks students whether they are on a computer at home with other family members. Is there an association between age and sharing a computer? So here's our two-way table. So let's look at it. 12 to 13-year-olds said yes, they had to share a computer, and no is 10. Now, as they get older, look what's happening about sharing a computer. Yes, they shared a computer. No, they didn't. Is there an association? So here's what we can do. We can use find the conditional relative frequencies by just dividing joint frequencies and its column or row total. That's it. So we don't have to actually do any of the other stuff we did. We just take 40 divided by either row or column totals. So look at what we did here. There are 50 total 12 to 13-year-olds. 40 divided by 50 gives us 80%. 10 divided by 50 gives us approximately 20%. 47 divided by 72, because if you add the total 14 and 15-year-olds, take each of these numbers, divide by the total of 72. Take each of the 16 to 17-year-olds, divide by their total of 78. And the same thing for 18 and 19-year-olds, and we get all of these percents. Once again, each of these columns should add up to 1. So look at what it says. Sharing a computer. We start off with 80% of 12 to 13-year-olds share a computer. We end at 39%. No, 20%, and we end up with no at 61%. So is there a relationship? Yeah, absolutely. The table shows that as age increases, students are less likely to share a computer with other family members. So there is an association.